Welcome to yet another episode of Programming Problems. Today, we pass the halfway mark as we tackle point of incidence on day 13. Let's dive right in. We've arrived at Lava Island, but we don't see any lava. As we travel further, we move through a valley full of large mirrors. Given a 2D map describing a grid, we take note of the row or column at which our map reflects onto itself. For every vertical reflection, we add up the number of columns to the left of it. For every horizontal reflection, we add up the number of rows above it times 100. Considering all maps, what number do we get after summarizing all of our notes? In this first example, we have a grid where we can find a vertical reflection line. It is between positions 5 and 6. Thus, we take note of the number 5. In the second example, we have a horizontal reflection between positions 4 and 5. So, because this is a horizontal reflection, we take note of 400. And that's basically all there is to it in terms of problem description and examples. Are you ready for the solution? Let's start. The problem guarantees that there is always a reflection. So per grid, we have to check the possible horizontal and vertical split positions. The first two lines of our solution outline are simple, getting the data from the text file. Then we will loop over every grid, and we first find the horizontal split. After this, we find the potential vertical split by transposing the grid and running the same algorithm again. Then finally, we add the appropriate numbers to our total. Finding a split or a reflection point means that we need to check row per row. So we iterate over all possible starting points of the split, and if this is the point at which the grid reflects, then we return that position. We add 1 to account for one-based indexing of the rows. If at no point we find a reflection, then we return 0. Finding the reflection itself is done by considering pairs of rows. First, we start with 1 and 2. This does not reflect, because the two rows are not the same. So we move on to the next possible starting row. Again, this does not reflect, so we check the next one. Once more, no luck. Finally, we see two rows that are the same. Now let's expand the reflection and see if it still reflects. Turns out that it does, so let's expand once more. And also at this step, the reflection still works. Since there are no more rows to check beyond row 7, we can conclude that this is indeed the reflection point, so we return 4. The algorithm to check if the grid reflects from a given start row looks as follows. Based on the starting row, we track the lower and upper row of the reflection. While it stays within bounds of the grid, we just keep checking if they're equal. If we run out of rows to check, then we can return true as we know it reflects fully. Now, we already know how to get the reflection for a grid, but checking the vertical reflection requires us to transpose the grid itself. Here's a short function to achieve this, with a visual example of what it means to transpose. Then lastly, why can we just add both the horizontal and vertical result without checking? Well, we are guaranteed to have one reflection line, so the direction in which there is no reflection will always return 0. And that's it for part 1. Let's move on to part 2. Turns out that every map has exactly one smudge. This means that one of the dots or one of the hashes should be the opposite type. In every map, it is up to us to find the location of this smudge and fix it. This causes a different reflection line to be valid. After fixing every smudge, what number do we get after summarizing all of our notes? Here we fix the smudge in an example from part 1. Do you see how changing the top left character completely changes the reflection line from vertical to horizontal? Let's see how we can do this as we check out the solution. The outline of the problem remains exactly the same, but checking if a grid reflects at a given starting row needs to be updated. Note that the problem states that we need to fix exactly one smudge. So let's track whether we fixed one or not as we set fixed one to false. Then for every possible starting row, we check if the rows are the same or not. If they are not, then this is a possible candidate to apply a fix to. First, we'll check if we already fixed one smudge before. If so, then we return false. Else we possibly fix our first smudge if it is fixable. If it is, then we mark fixed one as true. If it is not fixable, then we also return false. Now let's look at what it means to be fixable. Of course, if we must change one and only one character, then 2 rows are considered fixable if they only differ by a single character. This function loops over 2 rows at the same time by zipping them up and then counting the differences. And that was it, 2 more stars in the bag. Thank you so much for watching, and please consider liking and subscribing if you appreciate today's solution. Let's get back at it again tomorrow, and bye for now.